All right, welcome to Chapter 2, Section 2. We're going to learn this thing called synthetic division today. In Section 1, we talked about synthetic substitution. Now we're going to do something called synthetic division, which is basically the same concept. And we're going to talk about two theorems, the remainder theorem and the factor theorem. Okay, remember, theorems are always true. Okay, so that's all that word theorem means. So rules in math that are always true. We're going to talk about the remainder theorem and the factor theorem. The objective is to use synthetic division and to apply the remainder and factor theorem. So exactly what the title of the section is. Okay, so let's get started. First thing we have is this remainder theorem. The remainder theorem. Now, the theorems aren't going to make any sense until we actually do an example. So write down the remainder theorem, and then we'll do an example. And hopefully after we do that, it will make some sense. Okay, so it says, when a polynomial, any polynomial, p of x, is divided by x minus a, the remainder is p of a. Okay, so that won't make any sense until we actually do an example. Okay, so down here we have example 1. Okay, it says divide p of x equals to x cubed plus 5x squared plus 5x minus 2 by x minus 2, or x plus 2, sorry. Okay. So we're going to use synthetic division. Okay, we're not going to do long division. We're going to use synthetic. And we do it the same way we did in class in the first section, in the box. Now, in the box is the tricky part. It says we're dividing by x plus 2, but the theorem says x minus a. So what this part means right here, this x minus a part means, you have to use the opposite of a when we're doing synthetic division. We have to use the opposite. The negative a means the opposite. So if we have a plus 2, we're going to use negative 2 in our synthetic division. So we're going to divide with negative 2. And then we're going to put all of our coefficients. So 1, 5, 5, negative 2. We're going to skip a line, and we're going to put a box in the bottom right-hand corner. Okay? So let's do our division. Okay? So we are going to, first, we're going to drop down the 1. So we have 1. 1 times negative 2 is negative 2. 5 plus negative 2 is 3. 3 times negative 2 is negative 6. 5 plus negative 6 is negative 1. Negative 1 times negative 2 is positive 2. Negative 2 plus 2 is 0. Okay? So, what this tells us is this. Okay? That if I take my original equation, x cubed plus 5x squared plus 5x minus 2, that it's equal to x plus 2, which is what we divided by, times, and then what we have here is our new coefficients. Okay, we have down here our new coefficients. So, if we started with an x cubed, this will now be an x squared. So 1x squared, and then we just continue on, plus 3x minus 1. So, x squared plus 3x minus 1. Okay? And what this tells us down here, this 0, this tells us that there is no remainder. The bottom right-hand corner box is always the remainder. So this one has a remainder of 0, so there is no remainder. Okay? So that's how you do synthetic division. The answer are the coefficients at the bottom of the screen. So this is our answer to the division problem. X squared plus 3x minus 1 with 0 remainder. It does not have a remainder. Okay? The next theorem that we're talking about is called the factor theorem. And it says, for a polynomial p of x, x minus a is a factor if and only if p of a equals 0. So only if the remainder is equal to 0. So it's a factor if the remainder is equal to 0. So if we go back here, x plus 2 is a factor because the remainder was 0. Okay, so that's what that means. Okay, so example 2 says, if p of x equals 2x to the 4th plus 5x cubed minus 8x squared minus 17x minus 6, determine whether each of the following is a factor. Okay, so the first one is minus 1, x minus 1. So what goes in the box when we're doing our synthetic division? It's the opposite of negative 1, which is 1. And then let's put in our coefficients, 2, 5, negative 8, negative 17, negative 6. There's no need for a placeholder. 4, 3, 2, 1, 0. So no need for a placeholder. Okay, so let's drop down our 2. 1 times 2 is 2. 5 plus 2 is 7. 1 times 7 is 7. Negative 8 plus 7 is negative 1. Negative 1 times 1 is negative 1. Negative 17 plus a negative 1 is negative 18. Negative 18 times 1 is negative 18. Negative 18 plus negative 6 is negative 24. So is x minus 1 a factor? If this is 0, it is. If it's not, it's not. So not a factor. It has to equal 0. So not a factor. Okay? Let's do the same thing now with x minus 2. So instead of minus 2, we're putting in 2. Same coefficients, 2, 5, negative 8, negative 17, negative 6. And we want to check and see if this is a 0. So bring down the 2. 2 times 2 is 4. 5 plus 4 is 9. 2 times 9 is 18. Negative 8 plus 18 is 10. 2 times 10 is 20. Negative 17 plus 20 is 3. 2 times 3 is 6. Negative 6 plus 6 is 0. So is x minus 2 a factor? The remainder is 0, so it is a factor. So this one is a factor. This one is not a factor. Okay, so that's what that means. If the remainder is 0, it must be a factor. That's what it tells us. So if we look at this equation, and this is the same equation that we just did on the previous page, so if you look back, 2x to the fourth plus 5x cubed minus 8x squared minus 17x minus 6. Here is the problem. Okay, so here it is. So, if you notice, which is one of our x-intercepts? X equals to 2. And if you notice, what was one of our factors? X equals to 2. Okay, so that means the same thing. X-intercepts, factors, solutions are all equal to the same thing. What else do we know is a solution to this? What else is a 0? So here's 0, negative 1, negative 2, negative 3 is one of our other solutions. And notice it's an exponent of 4. It's an exponent of 4, so we should have 4 zeros. And here are the other two, but there's something a little bit, it doesn't actually go through 1 point. It actually comes above and comes over. So there's actually 2 here, but they're both decimals. Okay, so unless we're using our calculator, we won't be able to find those just yet. So we'll get to that in a later section, how we actually find those zeros. We're only worried about now the whole number 0. So 2 and negative 3 are zeros of that function because that is where they cross the x-axis. They're zeros. Okay. Example 3. If x equals 2 is a root, so it's telling you 2 is a root, of 2x cubed plus 5x squared minus 23x plus 10, find the other roots. Okay, so this is what you do. To find the other roots, how many should there be? There should be 3 because this is an exponent of 3. This is how you do the problem. Okay, we're going to do synthetic division. So 2, 5, negative 23, 10. And what number do we put in the box? It says x equals 2. It doesn't say x plus 2 or x minus 2. It's saying it is equal to 2. So 2 goes in the box. Okay, so let's do synthetic division. So 2 times 2 is 4. 5 plus 4 is 9. 2 times 9 is 18. Negative 23 plus 18 is negative 5. Negative 5 times 2 is negative 10. Negative 10 plus 10 is 0. So is it a factor? Yes, it is. Okay, so this is what you do. Once you determine, I need to move all this. Okay, so I'm going to separate this page here for a minute, so bear with me. All right, so once you show that it is a factor, you have to show that that number is a factor. This is how you finish the problem off. So in the first set of parentheses, you use your original 0. So instead of 2, when you put it back with x, you have to switch the sign. So x minus 2 is a factor. And then you put the remaining coefficients down here. So we started with a cube, so now we have to drop this to an x squared, this to an x, and this is our constant. That goes in our new set of parentheses. So 2x squared plus 9x minus 5 are our other factors. Okay? So we have a couple choices here. Okay? We can factor this to find the other zeros, or we can use the quadratic formula. It does not matter which one you choose. It will give you your other factors. Okay, so this one is x equals to 2. That's one of our factors. Now, let's use the quadratic formula to find the other ones. Okay, so x equals negative b. Our b is 9, so negative 9, plus or minus b squared, so 9 squared is 81, minus 4 times a, which is 2, times c, which is negative 5, all over 2 times a is on the bottom. 2 times a is 2, so 2 times 2 is 4. Okay, let's simplify. Negative 9 plus or minus, let's see what the square root is equal to. 81 minus 4 times 2 is 8. 8 times a negative 5 is negative 40, all over 4. So x equals negative 9 plus or minus, minus a minus, 81 plus 40 is 121, all over 4. Okay, continuing on. Let me extend this a little bit. So x equals negative 9 plus or minus, square root of 121 is 11, all over 4. Okay, so let's figure out what our other two answers are. So x equals negative 9 plus 11 divided by 4, and negative 9 minus 11 divided by 4. So negative 9 plus 11 is 2. So we have 2 divided by 4 is 1/2. There's another one of our answers. And negative 9 minus 11 is negative 20 divided by 4, so negative 5 is our other answer. Okay, so what are our roots? Let me move these up. Move these up here. So we have two answers. We have 2, positive 1/2, negative 5. So let's recap. First step is to do synthetic division with the original 0. We then take our coefficients from the remaining number, and that goes in our new set of parentheses. And then you can either factor 2x squared plus 9x minus 5, or you can use quadratic formula. I always use quadratic formula because it always works. Once you do that, you get your two other answers that happen to have been 1/2 and negative 5. Okay, so we're going to do many more examples in this section. This is a more challenging section. Hopefully it makes some sense. We'll learn more tomorrow. Thanks for watching. Have a good night, and I'll see you tomorrow.